Thank you. Hello, everyone. Welcome to my career story. I'm very excited to have you here. Today, we'll be talking through a number of topics that cover starting off going through a career path in metallurgical engineering. With us today to give us insight on this career path is Dr. Phillip. He's the Materials and Corrosion Engineering subject matter expert for INEOS O&P UK, Grangemouth, where he acts as a technical authority on all materials and corrosion-related matters. He holds a PhD in materials, MSc in corrosion control engineering, and B.Eng in metallurgical engineering. He has over 11 years experience in the control and management of corrosion in new, build, and aging assets. His experience cuts across the upstream, midstream, and downstream oil and gas industries, as well as process and power generation distribution industries. He's also a visiting professor to the African University of Science and Technology, Abuja, and he's a chartered engineer and fellow of the Institute of Corrosion. He holds a professional memberships of the Institute of Materials, Mining and Minerals, and NACE, the Worldwide Corrosion Authority. Thank you so much for being with us today. It's really great to have you on this interview.
Thank you very much, Stephanie. The pleasure is all mine, and I'm really happy to be here.
Thank you. So very quickly, we'll be looking at teenagers. Most of our audience and people who are going to be speaking to are teenagers. So there's a lot happening with work currently, and many people are yet to come to terms with the changes that are going on. So we are going to start by looking at what engineering and metallurgical engineering is all about, because for some of them, they just say, I want to be an engineer, and they don't know what metallurgical engineering or things like petroleum engineering are. So would you please give us a description of what the engineering field and metallurgical engineering is about? Thank you.
That's a great question. Engineering is really wide, as you very well know, and it affects our lives in very many different ways, from how we drive our cars safely to how we consume food and medicines. But specifically talking about metallurgical engineering, or metallurgy as it will be called in certain places, it really is talking about studying the physical and chemical behavior of elements and how you can combine these elements together to form alloys and the uses they can be put to. Because in reality, if you take the natural elements that we know from our periodic table, or even those that are made in the lab, they're not in the form that we can use them. We cannot use them because they do not have those desirable properties. Now, for engineering purposes, you need to have properties such as strength to bear loads, and you need to combine these elements in certain ratios for you to be able to achieve that. So we talk about lots of iron and steel, we talk about alloys. These materials have been carefully studied and they've been combined in proportions that help us to undertake engineering applications that allow us to live in the modern world today. So metallurgical engineering itself is a very broad field. It's exceedingly broad, and there are certain aspects which I can talk about which the teens might be able to relate with. Now, if anybody follows the news, one of the things that's being talked about now is extraction of materials from the ground. Why are we talking about this? Because we're really blessed with these natural resources. And when you talk about extracting these resources from the ground, you're really talking about extractive metallurgy. In engineering, we try to keep the terms simple. So extractive metallurgy, getting it from the ground. It's getting an ore from the ground, purifying it, and we can either use water or we use heat. Now, if we use water, we use a term hydrometallurgy to refer to that, and if we use heat, we use a term called pyrometallurgy. So you might see all these jargons, but really, if you break them down, they're things that you can really understand. There's also an aspect called physical metallurgy, which deals with how metals change. and how they behave when you change the relative proportions. So if you have, let's say, copper and there's 90% copper and you put in 10% nickel, it will behave differently from when you swap it around. So 90% nickel and 10% copper. So that's a different field on its own.
Mm.
And then you deal with how a material will respond to a load. Mm-hmm. So if you put a load on it, let's say you build a bridge and you have steel in there, how's it going to respond when the weather is cold? How's it going to respond when there's too much of a load on it? That deals with mechanical properties. So we refer to it as mechanical metallurgy. Then there are other specific specialties that are offshoots of materials and metallurgical engineering. So you can talk about corrosion. We see this every day. We talk about it all the time. Our cars corrode. But what is really happening? We're talking about an interaction of the material and its environment and how that material can be protected from that degradation that happens. For example, we have huge projects going on all over the country. We've got pipelines that are being built. Now, we need people who can weld the materials together. Even if you've got long sections of steel, they wouldn't be long enough to convey the fluids that you want from one location to the other. So you really need welding to be able to join those materials together. And there's an understanding of how much heat you need to put into the material, how well the weld is made in terms of its properties. And there's a lot of testing that goes into that. There's also a lot of things happening in the additive manufacturing space where we start to talk about specialty ways of making metal. So that deals with powder metallurgy. How do you move away from the typical methods that we've used for thousands of years, and then you use forces to compact a powder together to give you something which is of use, like bearings. So these are all things that are under metallurgical engineering. And then in the wider materials engineering space, there are topics or subjects like biomaterials, which we talk about these days because we want to have implants and we have to monitor things a bit better in terms of our health. We have polymers and composites. We have ways of harvesting power these days. So these are big topics of today. Drug delivery for cancer treatment, water treatment using graphene, solar cells, all of these things. These are all aspects of metallurgy, aspects of materials engineering, aspects of these big subjects under engineering. And I think it's a very, very exciting, yes, innovative field, and it's expanding.
It is. Wow. I'm tempted to be a metallurgical engineer if I can go back to school. This is awesome. It's really insightful, and I love the range of things and how it connects to what is going on with technology in our world. And listening to you, I could hear the excitement in your voice and the passion with which you were speaking. So you've had a long journey of more than 11 years, because you've had 11 years experience, but you've been working, or you've been studying before that time. So what was it like? What was your journey like becoming a metallurgical engineer? Can you walk us through why you chose it and how it has been so far?
Well, it's a very interesting journey I've had. And the fact of it was, I knew I wanted to be an engineer quite early on. And I didn't know if it was the fascination with the hard hats and the attire, but I really, really wanted to be an engineer from about age 14. And that was simply for two reasons. One, I wanted to do something different from what everybody in my family was doing at the time. Most people were opting for medicine, and that's what a lot of people have found themselves doing in my family. So I wanted to be an engineer just to do something different. But in depth, I found that I was fascinated by subjects like maths and physics, and they seem to explain everything about the universe. They seem to explain even down to music, because I was fascinated by music as well. So maths explained a lot about music and timing and tuning and all of that. But I didn't choose to become a metallurgical engineer. I embraced that choice, which initially was made for me, because what I applied for was slightly different. And in a sense, life has a way of making us go in the direction we really want to excel in. So I'm quite glad I went in that direction. And because I loved maths and physics and a bit of chemistry, I wasn't very keen on chemistry. I was good at it, but I wasn't very keen on it. But those formed the basis of my sojourn or my experience or my journey into the world of engineering. So I had the background and an understanding of the fundamental principles. So I started enjoying the prospect of being an engineer, and then eventually graduated from university, having done a very lovely undergraduate project. Now, it was around that time I really started seeing what I could do with what I had been studying, because at that time I became aware of the fact that I could solve problems. And that was really what got me into engineering in the first place. I wanted to solve big, challenging problems. So because I managed to do that project and delivered it so well, and it was quite complicated, I got published quite early, and that, in a sense, started to shape my career. Then I started thinking about becoming a researcher as well. However, I took a detour and I went into the world of business, and I worked for KPMG, which is one of the big 4 consulting firms in the world. And there I got an exposure into companies and balance sheets and tax and mergers and compliance with the law. So I started wondering and thinking, how can I use the knowledge I already have from engineering in this area? And I found that I actually could use it quite a lot. First, I worked in the energy and natural resources group. So that meant that I needed to look at companies and businesses in oil and gas, those that were extracting the oil and gas from the ground, and those that were supporting their services, so supporting those companies with services. The next was that I had to look at companies that were in the solid mineral space. So I then developed a lot of knowledge around oil and gas, upstream oil and gas companies, petrochemical and refining companies, and then companies working in the solid mineral space. And that, to me, opened my eyes to how business is done. So I still had my first love, which was engineering, and I said I had ventured into business, which was really interesting to me, but I came to a crossroads, a sort of crossroads at that time. I then had a scholarship to study for a master's in corrosion control engineering, and it was quite tough to leave a job I loved, lifelong friendships that I had cultivated and developed, and an environment that actually spurred me into thinking differently, because it was a really great work culture we had. So I did leave, and I studied for that MSc, and I graduated at the top of my class. And that was because it was really interesting to study at Manchester, which of course was the top corrosion research center in Europe. And I think it still is to date. Now, I'll come on to why I chose Manchester later, but having worked hard, I was told I worked hard. I didn't believe I was doing any hard work because I was really interested in the subject. I then got a funded position to do some research for a company. And that ended with me getting a PhD, the company getting some good results, and I had worked in a big project. So from that point on, I then started a different career. So you can see that I've had different takeoffs in my career, and all those different areas are coming together in a nice fashion now, because they're helping in a sense to shape the decisions I make on a day-to-day basis, because I have to look at the business impact of a decision I make as an engineer now, and I have to understand how we comply with the law, because there are laws guiding what I do as an engineer at this point in my career. So all of it has come together nicely, and no knowledge has been wasted. That's been my journey, and it's now shaping up nicely for me to move on to a different part of my career. So I think it's been interesting so far.
Yes, it has. It has. And I think it's a very big encouragement to people who come out of school and probably don't get to work in an area that is exactly, or the areas they expected, because sometimes these other jobs that they get are connected to what they studied, but it's just not what they had in mind initially, and they'll be able to look beyond that and see the value of what they have acquired. Now, you spoke about your time in university and the point where you had that realization that you could solve problems and how it made a difference for you. Now, I would want to know, what do you wish you had known while in college or before you started your career? Because I'm very sure when you became conscious that I'm a problem solver, I can use this knowledge I'm acquiring to solve problems, it did something to your mind. So what did you wish you had known, and what do you think young people, teenagers, young adults studying engineering generally should know about career and learning and work generally? Thank you.
I think that's a very great question, and it's a very relevant question for this time. What I wish I knew when I was at university or very early on was how to do business or understanding business in general. So I wish I understood business a bit better. Of course, when I moved to that stage of my career, working for KPMG, I came to understand quite a lot about business. And in fact, it was through conversations with some of the people at the firm, specifically the head of the section I worked in, he referred to as a partner, that I came to understand that you could commercialize certain ideas. I didn't know that we were set up to do that much in Nigeria, but actually there are laws to do that. And that's something that a lot of young people will face. So how do you protect an idea that you've got? How do you commercialize an idea that you've got? How do you run a business? And lots of young people have ideas, but there's not a lot of support, or they don't think they have a lot of support which they can access to then progress those ideas. And that was something I wish I knew a lot earlier in life.
Wow, that is very, very timely of you to say, because a lot of young people, you would not know how many young people have ideas till you put out a competition and say send in your video entries, and you see how many people are sending in ideas. And when you listen to young people speak, you hear them talk about how are they sure their ideas are protected, or how they sure, okay, when these investors or people that they are speaking to listen, how they sure those ideas are safe. So can you say a word about that? Because over here in Nigeria, I'm not really, I've not researched too much into it, but I'm not sure what structures or how strong the structures to protect intellectual property are. So what would you say to someone who has a lot of ideas in Africa or in Nigeria? What are their chances? Just briefly, what would you say to them about executing?
They've got a lot of chances. You've got a structure which helps you protect your ideas. That's around patents, trademarks, and there are people who can help you with that. So there are lawyers that can help you with that. I would say just take some time to structure that idea properly, get the right support, and then you will then be able to protect that idea either with a trademark or a patent.
Thank you very much.
And I think the Ministry of Industry supports people in doing that in Nigeria.
Yes, yes. So what should teenagers consider when choosing where to study? You spoke about how you chose Manchester because it was really strong in the area you wanted to study in metallurgical engineering. So what should they consider in terms of the location, the institutions, and how can they acquire other valuable skills while they're at school?
Right, so you've already touched on one of the things which is fundamental, which is getting to study in a location where you will get the right exposure to that subject. That was one of the drivers for me. Having a place where you have the right support is also key. Now, exposure means you will be exposed to cutting edge technology, you'll be exposed to the leaders in the field that you're looking at. And support means that those people will be willing and able to give you that encouragement. So one of the things that I enjoyed in my time at Manchester was that we had over 80 people who were active in that field and could support me in any way I needed. In fact, the funded position was something that came out of an assessment of what I had done and what industry partnerships we had. So that is very key. The other thing that I would say is that choosing a specific environment means that you will have a specific set of friends which you will be able to interact with in that environment. So you would have great people to bounce ideas off of. All right, so that is something I would say is very, very key if you want to choose a location to go and say study or further your studies.
Thank you so much. Thank you very much. So what would you say to graduates who complain that there's a gap between what they learn at higher institutions and what the workplace needs? Because we have a lot of that. Some people are ditching school because of that mindset. They feel there's no need to go to school since it doesn't relate to what we're doing in the workplace. So what okay, to what degree is what you learned in secondary school, what was what you learned in secondary school applicable to your journey as a metallurgical engineer? Did you really use what you learned in school, both in school, as in college, and at work now? How important was that foundation, and how can children who lack the strong foundation bridge existing gaps?
I think that's something that we really need to look at as a country, because a lot of people are disillusioned with the idea of having to go through the educational process. Now, I did say very early on, talking about my career, that I had a very strong background in physics and maths, and those two subjects encouraged me to become an engineer. I also had a very, very good appreciation of chemistry. So when you put chemistry, physics, and maths together, automatically you're talking about an engineer. And you're talking about exposure to not just engineering, but a wide variety of things. I did say I worked in consulting. So I took my engineering ability and applied it to business. Now, how did I do that? I learned how to communicate properly. I learned how to be succinct. I learned how to interact with people. So there are lots of things that you learn in the core subjects in school. And then there are some other things like developing interpersonal relationships, friendships, and then cultivating networking. Those are things that you would learn, albeit informally, in school. There are other settings where this can happen, but school presents a very, very great opportunity to do that. I also learned other languages, and as I mentioned, I had a great research career before I moved away from that, and I went for quite a number of conferences where I had to speak French or another language, and that was really helpful. So all these things come together. Now, that's perhaps one box, or that's one route. There's another route where you can come out of secondary school and you decide that you want to go through an apprenticeship, and you can apply to a company to do an apprenticeship with them. And that company may be able to put you through school while you're working for them. So there are many opportunities out there. But I find that being a lifelong learner is the biggest opportunity. If you condition your mind to say that you want to learn and you want to learn anything, and you decide that your future is whatever you make of it, then you will be able to progress. So it doesn't end at school, but school is absolutely important for us to set a foundation and build upon.
Wow. Wow. You struck it exactly as you talked about being a lifelong learner, because right now there are a lot of opportunities for teenagers and young people to learn online, but there's a mindset about physical environments and all of that. But let me not dwell on that. Let's move on to jobs and volunteering opportunities. What do you recommend for people who intend to go along this career path? What volunteering opportunities are there, or internship opportunities, and how can they crack the employment code? How can they position themselves to get jobs?
So in a sense, we've just built up to that from the previous question. You've got to be a very good communicator, because you will have interviews and you have to speak about your ideas. So you've got to conceive those ideas, articulate them properly, and then communicate them. Now, if you're talking about leveraging or getting into industry in other shapes or forms other than sideways, you have to also think about what you want to do. So it starts with us, or starts with the individual taking a step back and saying, what do I want to do? What are the things I can do? Find out what opportunities are out there and then go for them. In the first place, do not limit yourself to what you studied. There's a clear example here, because some of my roles have not been in the area I studied, but I had competencies which I could use. So what I would say is, have an idea of what you want to do. Speak to people if you don't have an idea about what you can do with whatever you've studied, and then apply yourself. If you're a lifelong learner, you will learn on the job and you will move to other jobs. So there are lots of things that people can do. There are lots of skills that you already have as an individual, which you develop in school. It really is whether or not you can apply that to any job that you get.
Thank you very much.